So we're going to take a look at problem number 15 on the chapter test for chapter 8, extended response, form B. So we have a small airplane that's flying at a constant speed of 300 miles per hour at a bearing of north 55 degrees east. So I'm going to make a little drawing. And we like colors, so there's my axis. And we have east, and we have north. And we have this airplane that is flying at a diagonal at a rate of 300 miles per hour at north 55 degrees east. And so I'm going to add some helpful lines. Uh-oh. Our rally flag just fell down in a place where I can't get to it. Oh, that's not true. I can't get to it. So I have drawn a horizontal line that is obviously parallel to the ground, just for funsies, because you can't beat fun. Then it says there's a 30-mile-an-hour wind blowing due east. That means it's blowing, I'll use a different color, red. It's blowing east at 30 miles per hour. And that is going to create a vector. So we have our vector right here. Doing vectors. Oh, I'm sorry, yes. Do you need one or two?
Just one.
Okay.
I'll return it at the end of the...
Yeah, no worries. I'm sorry. So we have this green vector, and we are being asked to find the plane's actual speed and the direction. So, and a vector means magnitude and direction. No big deal. And here we go. I'm gonna. All right. So if this is a 55-degree angle, and I know this is a right angle, that means this angle right here has got to be a whopping, I have it written down of course, 35 degrees, because 35 plus 55 is 90. Obviously I probably should have just done it, which means that this angle here is 145 degrees because these two together are supplementary. Now I have one side length, two side lengths, and an angle. This, my friends, is a time for the law of cosines. So I'm going to shrink this a bit, and let's remind ourselves what the law of cosines is. Ellie, are you ready for the law of cosines? This is great stuff. You don't have to write it down. Just you can memorize it. We know that a squared is going to be equal to b squared plus c squared minus 2bc times the cosine of angle A. So let's do some labeling here. Let's call this side length A, which means this right here is angle A. That's going to make this B, that's going to make this C, and now we can plug into our equation. So we have a squared is equal to 300 squared plus 30 squared minus 2 times 300 times 30 times the cosine of 145. Getting all this, Ellie?
Yes.
Yes. See?
Yep.
It's really not that hard.
Oh my.
So let's crunch some numbers. 300 squared is 90,000. 30 squared is 900 minus 2 times 300 times 30 is 18,000 times the cosine of 145. So my crappy calculator here doesn't do cosines. Talk to me thinking about that. So I know you can't see this, but I'm going to take my super cool calculator. And I'm going to say 145 and hit the cosine button. And so I get 18,000 times negative 0.819. And folks, this does make sense. The reason why a negative makes sense is if you have your unit circle and you have your angle of 0, 45 is going to be, 145 is going to be over here in the second quadrant, meaning this value, the x value, is going to be a negative. And that's why it makes sense that you have a negative here. And that's 900, right? So then 90,900 minus this thing here. So I'm going to take my number, I'm going to multiply it by 18,000. And I get, so now I have positive, because the negative times a negative is a positive, 14,744.74. I sell my 90,900. So I'm going to add 90,900. And so I get this ridiculous number. Oh, shoot. Have you ever had the problem when you're using your iPhone for your calculator and it just doesn't work right?
Yes.
Yes, I'm having that. Oh, but you know what? I don't have to use my iPhone anymore. I can use this. Great. So we have 90,900 plus 14,744.74, and I get that beautiful number, 05644.74, 100,005, and that is equal to a squared. So what do I have to do with this number? I gotta squirt it. And so that means that my length is 325. And so I have found my magnitude. The plane is actually traveling at a speed of 325 miles per hour due to the extra wind of 30 miles per hour blowing due east. So now, we are going to have to find the direction. And so we already know that it has a direction of 55 degrees over here. So we need to find this angle right here to add it to this 55 degrees. And to do that, we're going to have to go to the law of cosines. Isn't it a wonderful thing when both the law of sines and the law of cosines all come together? I do think it is quite a beautiful thing. So I'll scoot this over here, and I'll just work below it in a different color. Now the law of sines says that the ratio of a side length and its opposite angle is they're all going to be equal. So that means that this angle, so the sine of, let's call it angle x, divided by the opposite side length is going to equal the sine of, well, I have this angle, so let's use that. It's the sine of 145 over this side length, 325. Okay. So, I'm going to jump to my calculator that you can't see to use the sine. So we have 145, find the sine, and so I get, that's equal to 0.5736. So we have 0.5736 divided by 325 equals, okay, not a big deal. And so now I need to multiply that by need to multiply by 30 because that's going to get rid of the denominator here, bring 30 over here. So times 30. And so I get the sine of x is equal to 0.0529. Alright, and so now I'm going to have to use my invisible calculator again. And so I'm going to go 0.05295, hit the second button, and so now I'm using the button. And I get 3.35. And it says to the nearest tenth. Oh, that's the speed. Yeah, okay, around the speed, okay. So we know that this angle here is 3.35. 3.35 plus 55 is going to be north and 58.3 degrees east. And there we have it, folks. I know. You're thinking, how can I possibly have more fun than combining the law of sines and cosines? And the answer is, I'm not sure it's possible. So, you're welcome.